We now take a step away from the syntax and features of the shell programming language itself and focus on some of the support tools that are available in Unix for shell programmers. In particular, we want to focus on the class of utility programs that are dedicated to text processing. This class of programs is known as the filters. Oftentimes, when we are developing a shell script, we need to perform some text processing. Often we need to analyze the text that is produced by a program or is contained in a file, or we may need to present this text to a user in a user-friendly way. And there is a whole family of programs that are provided to us, mostly for use by programmers, that are catered to exactly this sort of text processing. These family, as I mentioned, is known as the filters. Let's have a look at them. We first need to understand what a filter actually is, so let's have a look at that. And a filter is a command line program that has the following properties. The first is that it takes standard input. Standard input means that it can read characters from the keyboard that the user types. Now, if it doesn't take standard input, then it can also read the contents of one or more files. In other words, standard input has to come from somewhere. It either comes from a file or it comes from a keyboard. And all these filters work the same way. If you specify one file on the command line, then it will read that file and use that as its input. If you specify several files on the command line, then it will read all of the files and use the contents of all of the files as input. And if you specify no files on the command line, then it will read the input from the keyboard. The second property that all filters have is that they perform some processing on the above data. In other words, whether the data comes from a keyboard or whether it comes from a file, that data gets processed in some way, and the different processing is what separates one filter from the next. Finally, the filter produces output based on that input. In other words, it produces output which is the results of the processing that it did in step 2. Now you might look at that list and say to yourself, well, surely all Unix programs are filters because they all adhere to those three properties. Well, that's not entirely true. So what I'll do is I'll show you first a Unix program that is a filter, and then I'll show you one that's not. Firstly, WC is a filter. Specifically, it does indeed take standard input or the contents of one or more files. I'll just prove that to you actually, because it is an interesting thing that you need to know about all filters. Let's examine how WC actually works. I'll do an ls-l in this directory, and I find a series of files and directories available. So I'll just do a WC, for example, of names.dat, and that is the number of lines, words and characters in names.dat. Then I can do a WC of star, and I get some error messages for the ones that are directories, and then I get the numbers next to ones that are not directories and a total at the bottom. And again, all of this is as you would expect. A filter will process a single file or it will process several files. Now the interesting thing is it will actually also process no files at all, which means that if you just type in WC by itself and press enter, then, well, it's just sitting there waiting. Now what's it waiting for? Well, it's waiting for you to type something on the keyboard. So I can do a little bit of typing here, do maybe 5 or 6 lines of input, 6 lines there, and finally, when I've finished typing all my input, I have to type the special key on the keyboard that says to WC, and in fact says to all Unix programs, I have finished typing, there is no more to type. And that key is, do you know what it is? It's the end of file marker, which is Control D. So I type Control D, and WC completes its processing. And I found that I typed 6 lines, 15 words and 85 characters, which I'm sure is correct. The interesting thing that I wanted to show you there is that it is actually possible to get WC, and in fact any filter at all, to not take any input from anywhere besides the files. So you can actually just get input coming directly from the keyboard, or of course there's the other way of getting input, standard input, which is to pipe it from another program. So that is another way of getting input into any filter. So please keep all of those techniques in mind when you're thinking about any filters, because it may not be obvious that some of these programs can be used in this manner. So having said all that, let's now have a look at an example of a program that is not a filter. Well, actually most programs are not filters, and I'll show you one in particular that's very common that you know quite well, and that's the ls program. That is not a filter. And there's a very simple reason that it's not a filter. It's because it takes no input. It does not take standard input. For example, we can of course do an ls of star on the command line, and that works, but if we just do an ls by itself, we still get some output. It does not at any point sit there waiting for us to type something on the keyboard, nor can you pipe anything to ls. Well, you can pipe something to ls, but ls will completely ignore what you pipe to it. So in other words, ls does not ever take standard input. So a good way to test, I guess, whether a program is or is not a filter is to simply ask yourself the question, can I pipe information from one program into this program and have it use that information in some meaningful way? If the answer is yes, then it's a filter, and if the answer is no, then it's not. And filters are actually used obviously to process the data produced by other programs and the data in files. That's what they're for. They are simple text processing tools. Let's have a look at some common filters. These are used regularly in Unix shell scripting. We have got cat, of course. You may ask yourself what processing is done by cat. Well, none, really. You could say that it's the no processing filter. Whatever input it receives, it just puts it straight back out to the screen. And yes, of course, because cat is a filter, it is possible to type cat by itself on a line with no parameters, and it will just sit there waiting for input from the keyboard, and whatever you type, it will echo back out to the screen. More is, of course, a filter which does exactly what cat does, except it does it one page at a time, so we've got pagination happening. grep, we'll look at grep a little bit later on in this chapter, and sort, we'll also look at sort later on in this chapter. We've had a look at WC already. T, we won't really have a look at that, but it provides a nice little facility to write information both to a file and to the screen at the same time. And then sed and awk are actually very powerful filters, and I'll spend a bit of time in this chapter explaining the use of both of them to you, because they are both tools that you really need to become familiar with if you want to be a proficient shell programmer. So for the rest of this chapter I will be explaining to you the following programs: grep, sort, sed and awk, and I'll also be having a little discussion about what a regular expression is, because you do need to know. So that's what the rest of the chapter looks like. Let's move on.